Okay, so we're continuing our sorting algorithms. We talked about the selection sort. We're moving on to the merge sort. So merge sort basically is a sort that is going to start with a list. It's going to divide it in half, and then it's going to sort each half, and then it's going to merge them together. But we're going to do this recursively. So we talked about the recursive before last chapter. So the idea is what? We're going to take the list, we're going to cut it in half, and then we're going to pay attention to each half. Then we're going to take it and we're going to do the same thing. We're going to cut it in half. Then we're going to pay attention to each half. And then we're going to cut it in half. Then we're going to cut it in half. And then we're going to merge them together. So sometimes for some people, this recursive thing is going to be hard to picture, it's going to be hard to understand, but not a big, huge thing. We're going to look at it, and then after a while, you're going to get used to it. And not necessarily you need to know all the detail of it. You're just going to know how to use it. And definitely is much better than selection sort. So the idea is we have this list, we're going to cut it in half. So we have this half and this half. We go along and sort this half, then we're going to sort this half, and then we merge them together to get the merge list. That's the concept. So how do we do it? We're going to have a function called merge sort. We're going to pass a list to it. So remember, from the recursive function, we have to be sure that we have a stopping point. So the first thing that we think about the recursive one is we need to stop it. So if the value is less than or equal 1, so if it's 1 or 0, or if it's for some strange reason becomes negative or anything, we're going to just return. We're not going to do anything, we're just going to return. We're going to find the middle midpoint by integer division. So we got our first list that's going to start. This is our first list that's going to start from the beginning of my list to the mid. And the second list, which is going to start from the mid to the end of the list. Then we're going to call the same function for the first. Then we're going to call the same function for the second. And then we're going to merge them. This is another function I'm going to be using here. We call them helper function to merge them together. So we cut it in half. We find the first half, second half. We call the same function on the first half, and we're going to call the same function on the second half. We're going to keep doing till we end up with the lengths to be 1 or less than 1. And then we're going to return. So remember, the recursive functions are memory extensive. That means, so when I am doing, we're going to calculate these things, then when we get to the merge sort first, this merge sort is going to be calling this function again. It's going to come back up. It's going to find its lengths. And then it's going to divide it in half. Then it's going to break it down in 2 more lists. It's going to call both of them. But remember, the first one is going to be executed first. So that means the first one is going to be called in again. And again, still be done with the first one. Then it goes to the second one. Remember, all of these things is happening in the memory. So when it's done with the first one, that means the very last section of my first list is going to go to the second part of that one, and it's going to keep building it up. So maybe if we look at the previous one, so we take this one, we take this list, we're going to cut it in half. Now we have this list cut in half. Then we have 1, 2, 3, 4, 5. 5 divided by 2 is what? 5 integer divided by 2 is going to give me 2. So we're going to do this list. And then we're going to cut it in half. It's going to be this one. Then we come back up. We're going to be looking at this one. We're going to cut it in half. That's going to give me this plus this. This is the length of 1. It's going to stay there. And it's going to do sort on this one. It's going to merge these things. And it's going to do the same thing with the other one. It's a little confusing, so we need some time to think about it. And again, you don't need to know all the detail of it. It's just that's the way it's going to work. So as you see, the recursion functions are very small, but it does a lot of work. So the computer does a lot of work. We write less code. So let's go look at the merge list, that if we have the first one and the second one and the values, how we're going to do the merge list. So for the merge list, we're going to have our first one, and we're going to have our second one, and we got the values. So we're just going to get the index for the first one, index for the second one, and we just have a J for the another index. So we're going to be checking to be sure that the first one is not going to go outside of my list. We're going to check the second one is not going to go outside of list. So we are looking at two lists, and these two lists, they may not have, most likely they are not going to have the same links. So we're going to go through both of them at the same time while we have element in both of them. And eventually we're going to be run out of one or the other one, or maybe neither one of them. So as far as we have elements in both lists, we go through it. We're going to check it to see which one is the smaller. Remember, we have two lists. We're going to look at the first element of both of them. And then we're going to add it to our values with J. Remember, the J is 0. And then we're going to add 1 to the I first. So this is the first one was smaller than second one. Not necessarily we're going to have the second one copied. We're going to keep doing this till we got the second one smaller than first one. So if the second one is smaller, we're going to put the second one in there. And then we're going to add the index for second one. And then we're going to add the J plus 1. So we're going to keep doing this till we end up with two lists of, we basically go to the elements of both lists till we run out of one of them. So when we run out of one of them, we're just going to copy the rest of it over. So two things can happen, not this, three things can happen. One is they both have the same length, so we are done. Two is the first one, we still have some left in it. So the way that we're going to do it is we're going to check if my index of the first one is less than the length of the first one. That means I have elements on the first list, but I don't have anything on the second list. So we're going to copy everything on the first list to the values. And we're going to check the other one. Remember, if this is correct, the other one is not correct. It's going to be either one. So if my I first is not less than length, that means I'm done with my first list. Now I'm going to be working on the second list, and I copy everything on the second list to the value. So we're going to have a class here. We're going to use the rand and the merge sort. We're going to bring the merge sort function in here. We're going to create a list. We're going to create a random number from 1 to 100. We're going to print the values, we're going to call the merge sort, and we're going to call the print. So if you want to compare the time of your merge list versus your selection list, you can set your timer before and after, and then you can compare the time to see how long it's going to take to do one versus the other one. So that's the result of this program. This is the list size, and then we are checking for the seconds in the merge sort, comparing it with selection sort that we had. And you can see that as we are increasing with the number of elements, the time is not increasing the way that selection sort was increasing. So if you put both of them in a graph or visualization, you can see the merge sort is kind of growing very, very slowly, and the selection sort grows very, very fast. So let's go through the calculation of this. So we're going to go through some calculation to figure out our big O, and in general, how do we calculate this big O for our algorithm? Basically, it's a mathematical way of finding it. So if we get n is a power of 2, that means n is 2 to the power of m. So any power of 2. So we are going to be calculating the, so that's our assumption. We're going to put it over there. So we're going to have 2 sublists, and then we're going to merge them. So we have 3 visits to merge each element, or 3n visits. We have 2 n's to create the 2 sublists. So the total is going to be 5n visits. Now we were going to put that together. So the Tn is the number of visits for the to sort the list of an element. So the Tn is what? We're going to do the half plus the other half plus 5n, which is going to cost for the merging. And if you put them together, we're going to have our, so that's going to be for the first. Then what's going to happen is we're going to take this one. Remember, we have one list, we cut it in half, and then we're going to take each half and we're going to cut them in half. So in this case, it's going to be what? We're going to calculate our n by 2, the half. So for the half of it, what do we have? We have the quarter of it plus another quarter. So that's going to be 2 of a quarter, and the 5n, which is going to be divided by 2 because you're going to have half of it. And if you put them together, it's going to be 2 times 2t of n divided by 4 plus 5n plus 5n. That's going to be our t of n for this one. And we're going to keep dividing it by 2. So the next one is going to be 8, and so on and so forth. And we're going to keep dividing it till we find something. Now, if we put this together for the k times, if we just keep going it for k times, then we're going to have 2 to the power of k, tn 2 to the power of k plus 5nk. So that's the formula we're going to come up with. And if we decided that we're going to do n equal 2 to the power of m, we just put that at the beginning. So if we do that, when k is equal to m, so our n becomes 2 to the power of m, and then the 2 to the power of k is going to become 2 to the power of m, and the 5n and m. Okay? Now, my t of n, so remember the 2 to the power k is my n. plus 5nm, and then my m is gonna be the log 2 of n. Remember, if 2 to the m is n, if 2 to the m is n, m is going to be log 2 of n. So that's part of the math that we are going through. Again, you don't need to know all the detail of it. You just go through it to understand what's happening. So for the big O notation, we are getting big O of n log n for the merge. So we talked about selection sort, which is big O n square. Merge sort is big O n log n. And definitely the n log n grows much more slowly than n square. And if I put the table back here, then you can compare it with the visualization of our table and our graph. So this is something that you're going to be working on for your first project, and you're going to be doing some kind of a report like this for your first project. And that should be the conclusion of our sort algorithms.